anyone see any drawbacks in this brave new world of observables? What could potentially go wrong at this point, for example?
Disposal?
Kind of, yes. So, by which you mean resource deallocation?
Well,
We've got a timer
like a
flying
timer
about now,
flying, yeah.
right? So that's true. So right now we have no way of disposing that timer, which kind of sucks. Okay, so let's put it like this. What is the benefit of being IEnumerable, being able to call move next? If something goes wrong in my prime number generator, what's going to happen when I call move next? How do we generally encode errors? Exceptions,
Yeah.
right? But the thing is, with a pull-based sequence, you're always going to be on the calling thread. So it's structured error handling to the rescue, right? If anything goes wrong, the error is going to be on the stack, the guy that called move next. What happens if something goes wrong somewhere down in the deep depths of the thread pool? Say we pushed off that prime number calculation to the thread pool, something goes wrong there. How are we going to know about that, right? We're no longer waiting for a response, you're pushing it to me. So we need to encode that in itself into this, well, let's say that's another notification type, right? At some point in the future, something might go wrong. So it's not enough to say that there's only two channels, one of which is the value, the next value, the other of which is saying there will never be any more values. There's another channel, a notional channel, which is saying actually something went wrong at some point. So structured error handling, as we know it, kind of goes away at this point. So unsubscribing, yes, or resource deallocation. There's another thing here though, where primes is a terrible example, but how do we know if we're done? Actually, nobody knows if there's a finite number of primes, right? So what if we're running this on a supercomputer, and the supercomputer calculates the final primary number? Who's going to know? Like, with our encoding as it is right now, we don't know. Our for each is only letting us say, all right, when you have another value, let's just print it on the screen. But we can't sort of capture when it's completed. So that's another shortcoming. I'm just going to kill this. Maybe to exit. Don't hold it work. Okay, so we can address two of those things. We can address the fact that we don't know when we've completed, and there may be some error right here. We'll come back to resource deallocation because it's a tiny little bit more involved. But one thing we do know is that notification is missing a trick. There's another type. Error. So exception, error. So when you look at this drop there, this guy's going to take an exception. Error. So type. Sorry. Type. Going to be error, and the error guy is going to be error. Brilliant. And error T, exception E, E. Okay, cool. Just before we move away, but let's just go back to this guy. Do you notice something about the typing here? Things we've been talking about compilers. When I'm calling complete, I have to specify the type, but when I'm calling next, the compiler can infer the type. That idea is called type mumbling, and it's pretty useful when you do start to, if you do start programming in a slightly more functional kind of way. Type mumbling is a nice trick to reduce the amount of overhead of typing that's left in the code. So again, you see it there. Anyhow, we were on observable, and we've just added errors to our logical streams of things. So we've now got a value, a completion, and an error. The other thing we wanted to address is the fact that we don't know when we've stopped. So we don't know when we've had an error, and we don't know when we've stopped, which coincides. So we'll build on for each, and we'll call it subscribe. And we already have an on next. We're going to have an action for on error, should we encounter an error, and an action for on complete. So let's do our little guy again. And here we can just do a switch on the notification type. Quickly we shuffle these out here, and when we have a value, we're going to say on next, and dot value. That will be set. When we have a complete, we have a on completed. Just invoke that guy. When we have an error, on error, let's pass through the error, which is n error. And redo source, observer. Now let's go back to our what we'll do is an overload of intervals. So we're going to stick with the temporal stuff so you can see what I mean. But we'll add an overload that will only notify you a certain number of times. So we need to say timer t equals null, t equals new timer, and here we can say if I equals count t dot dispose. Right. Not only that, but you tell the guy he's finished. It's very important. Observer dot observer. Let's send you the notification of the fact that you are now complete. So we'll go back to our program. We're going to say interval every second. Give me a notification. When we get that thing, we're going to say console right line. On error, we're going to say console right line. I don't know why it's doing this to me, sorry. And I also don't know my message, e.message. And then finally, console right line, console right line. Done. Good.